I realized that the rigid structures of code were not as cold as I had imagined. Beyond the glowing consoles, I saw a subtle conduction of light. Everything was connected, not just by wires, but by a sudden, clear intuition. This pack is specifically engineered to facilitate technical proficiency while encouraging poetic reflection on creative decisions. It is ideal for users transitioning from a beginner level to an intermediate level. All content is compatible with the non-commercial version of the software. Our files are founded on a singular principle: situated learning. Learning is not merely the transmission of abstract knowledge, it is a socially situated activity rooted in actual practice. The complete pack contains 9 project files. In this video, the first project is covered in full. The remaining files are presented through a brief demonstration of each. TouchDesigner is a high-performance visual development platform designed for real-time, interactive multimedia. At its core, it operates as a node-based programming environment. Operators connect within visual networks to manipulate procedural data flows. Developed by Derivative, the software provides a unified environment for integrating 2D and 3D graphics, video, and audio into complex reactive systems. The versatility of the platform allows it to operate across diverse creative and industrial sectors. Its applications extend from large-scale architectural projection mapping and immersive museum installations to real-time reactive visuals for global stage performances. Beyond the stage, it serves as a robust engine for engineering custom interactive media systems and rapidly prototyping complex technical concepts. Before proceeding, verify that your hardware is compatible with the software. You will need to create a personal account on the official Derivative website. This is essential for license activation and community access. The full software installer is recommended to ensure access to all features and updates as your projects grow in complexity. Additionally, the Derivative website offers high-quality free educational resources and tutorials that can support and expand your learning journey. The Moonlight project is segmented into 5 assembly stages. In the first stage, we create the dynamics of the waves while establishing the surface and color of the ocean. A visual texture is constructed using top operators. In parallel, chop operators generate channel data that modulates parameters within the top network. The result is a 2-dimensional image composed of RGB values. A dedicated top defines the ocean's final color grading, contributing to the environmental atmosphere. Once the ocean's colors and wave dynamics are finalized, these 2-dimensional textures become data sources for instancing in the second stage. Within a single geometry, pixel information drives position, scale, or color in 3-dimensional space. In the third stage, the moon is constructed. A simple circle is added to the scene's geometry. The fourth stage manipulates camera aspects such as movement and angle, contributing to the scene's cinematographic composition. The relationship between these stages can be observed clearly in the Geometry Viewer panel. There, we identify the grid that forms the ocean, the circle that defines the moon, and the spatial behavior of the camera. In the fifth stage, post-effects refine the environmental context, and the final image is routed to an outtop. Before constructing this network, it is essential to understand the different types of relationships that exist between operators in TouchDesigner. One type of relationship is the direct connection through wires. Wires are the colored lines that connect the output of one operator to the input of another. They pass data through the network. Another type of relationship is hierarchy. Hierarchy defines parent and child relationships between components. It does not primarily pass data, it defines structure. A third type of relationship is the link or reference. A link or reference is a grey dashed line between nodes that indicates one operator is getting data from another operator. This is an indirect dependency. No colored wire is required. These relationships form what we define as technical connections. They structure the functional logic of the project. However, another type of relationship exists: connections by spark. Sparks are non-apparent poetic connections. They interconnect distinct elements and create a new visual sense. This creative visual thinking approach can be better understood by returning to the Moonlight project. Observe these four elements: the ocean grid, the circle, the camera angle, the post effect. In isolation, each element produces a different meaning than when placed together within a poetic narrative. This creative connection, the spark, allows alternative visual results using the same technical structure. We now have a poetic storm in the desert. The technical connections remain, the poetic intention shifts. With these concepts established, the structural construction of the project begins. With the Moonlight project complete, we now move through a brief demonstration of the remaining files. The methods present in these files are not confined to the projects themselves. They can be replicated into your own work, adapted, combined, and rebuilt according to your own creative intentions. The Holorganic FX project is divided into 4 main stages. In the first stage, 2 top operators are connected to generate the dynamics of the holographic effect. A color layer is then added, completing the visual character of the hologram in 2-dimensional space. In the second stage, the source element is imported and converted into a geometric system within the scene, gaining depth and the ability to interact with environmental lighting. In the third stage, a light and a camera are added, establishing a basic render system. This render connects into the fourth stage, where the scene is unified, concluding with a bloom post effect and the output operator. The Generative Islands project is divided into 2 stages. In the first stage, the environment takes shape and color, generating the irregular surface of the islands and creating a grid effect. In the second stage, everything is rendered, a post effect is applied, and the final image is routed to the output. The cube dissolving project is divided into 4 stages. In the first stage, top operators and a palette component define the dissolution effect, establishing the shape and color of the visual element. In the second stage, the instancing technique interprets the scene in 3-dimensional space. In the third stage, the form is rendered and a post effect is applied. With the visual system complete, the fourth stage introduces audio reactivity. 2 chop operators handle audio input and output. A palette component analyzes the sound and separates the frequency bands. 3 select operators extract specific musical attributes. In this example, high, mid, and kick, each one triggering a distinct visual parameter. It is worth noting that audio reactive systems are relative to the sound input applied. The same logic can be replicated by adjusting a few parameters within the audio analysis component. The layered field project is divided into 2 stages. In the first stage, a network of pop operators drives the dynamics of the field and separates the layers. A top operator serves as a color reference for the solid. In the second stage, the geometry is placed into the scene. A post effect is applied, contributing to the final atmosphere. Explanatory notes have been added throughout the project as reference points during exploration. The Hybrid Lines project is divided into 3 stages. Although the network appears structurally simple, the first stage contains a special component where most of the visual results are generated. Back in the main network, the second stage applies the instancing technique. In the third stage, the scene is rendered. One notable aspect of this project is its high capacity for generating distinct visual possibilities. The Burst Cloud project is divided into 3 stages. In the first stage, the shape and colors of the cloud are established using top operators, with triggers from the chop family. In the second stage, the instancing technique is applied. In the third stage, a post effect is added, completing the final image. The Blue Matter project is divided into 3 stages. In the first stage, the shape and color of the matter are established. In the second stage, the pop family is applied directly to the scene's geometry. In the third stage, the scene is rendered and a post effect is added, completing the final image. If any of this resonates with your practice, you will find more information in the description below.